Stretches and shrinks are usually the most troublesome for students to graph, so we'll sort of analyze them here and hopefully it'll make sense. Here I have the basic function f of x equals the absolute value of x, and we're going to do some stretching and shrinking of this function. The first time I want to look at what happens if I multiply on the outside of the function by 2. So I have g of x equals 2 times the absolute value of x. So you can think about this over here. If x is 1, y is 1. If x is 2, y is 2. If x is negative 1, y is 1. If x is negative 2, y is 2. Over here, if x is 0, then y is 0. If x is 1, then y is 2 times 1, so it's 2. If x is 2, y is 2 times 2, which is 4. So what's happening is this 2 is doubling every y value from this other graph. So it multiplies by every y. So the effect that it has is this was a 1, now it's a 2, this was a 2, now it's a 4. The effect that it has is it's like a vertical stretch. See how the graph is narrower than it was here. You know, if you were to sketch these on the same picture, it'd be like right here. So this graph is narrower than the original because it's been stretched vertically. It's been pulled up. Now this one's a little tougher. We're multiplying the x by 2. And so, again, anytime I'm doing something with x, I need to think, okay, how do I get the same x value, or the same value inside as I had in the original function? So up here, if I want a 1 inside the absolute value, x would just have to be 1. Down here, if I want a 1 inside the absolute value, x would have to be 1/2. So what we need to do, anytime we're working near the x, we have to counteract what's being done to it. So since x is being multiplied by 2, we have to then multiply every x value by 1/2. The reciprocal, multiply x values by the reciprocal 1/2. So if this were a 3, you'd multiply all the x values by 1/3 so that the y values would stay the same. Okay, let's take a look. So you take the original graph again, and now you can see that if x is 0, well, y is still 0. Now, for y to be 1, x has to be 1/2. So if x is 1/2, y is 1. For y to be 4, x has to be 2, which is half of what it has to be up here. So if x is 2, y is 4. And so you end up with this graph where every x value has been multiplied by 1/2. So this x value here is 1, it's negative 1. Down here it's negative 1/2. This x value is negative 2. Down here it's negative 1. So at negative 1 down here you get a y value of 2 up here, and so on. So the way to think about this is, instead of stretching it vertically now, you should think about compressing this graph, shrinking it inward towards the y-axis. You're shrinking it by 1/2. So I like to say this one up here is a vertical stretch by a factor of 2. This is a horizontal shrink by a factor of 1/2. Up here we multiplied the y values by 2. Down here we multiply the x values by 1/2. So if the number's inside, you have to counteract it. If the number's outside, it affects the y. Number's inside, it affects the x. So if this were a 1/3 x, you would counteract it by multiplying all the x values by 3. So you would be stretching your graph away from the y-axis by a factor of 3.